So I guess we're just going. Okay. All right. So input, say it. And then 1 squared is 1, 2 squared is 4. Now we're going to fly. And then what am I doing? What is that noise for? Symmetry. Okay, so we got that flash over the y-axis or input output. Hey, I plug in 0. Oh, I get 0 minus 3. And then I plug in 1. I get 1 minus 3. So I'm here. I plug in 2. I get 4 minus 3, which is 1. Okay, so what happened with this graph? It just got moved. Anyone? Okay, now what we're saying here is, and I'll move my fat head here, so you need a haircut, shave. All right. What is happening to the parent function? So here's the parent. Parent's right there. So that would be down 3 compared to that. I plug in 0. Wait a minute. I plug in 0 and get negative 3. Negative 3 squared is 9. What the heck just happened there? It's because what I told you. What should you plug in first when it's x minus 3 in parentheses? 3. What's 3 minus 3? 0. That's the vertex. The x coordinate that makes that 0 on the inside of that parenthesis. That's the same for absolute value, square roots, any function that's moved right or left. You plug in the number that makes that 0 on the inside. That gives you the key critical value. In this case, the key critical value is the vertex. And then I plug in 2 and I get that 1. And then I plug in 4 and I get that 1 because 1 squared. All right, and then this one's the 4 value, 3, 4, and then I just didn't want to make a mistake there. So that 0, 9 does actually exist. It just a little bit off, to the right. And then I'll tell you what my last one is. But this one, 0, 0. But then when I plug in 1, I get 1. Wrong. Multiplied by negative 2. 2 squared is 4, but then times negative 2 is negative 8. This went too far. Okay, so 2 things happened on that one. It got flipped. And then here's a perspective thing you got to listen to. This 2 is on the outside of the function. I do like that I'm kind of showing this camera here. When I walk away, you can't hear me anymore because the microphone stinks. All right. But anyway, and then it's stretched vertically. That means in terms of the x-axis, it's pulling away from the x-axis. That was weird. Okay. So that's what's happening with that. Now I threw another coordinate plane up here because this is the most valuable. You ready? All right, and I'm actually going to do. There's an example later that I mirrored too close. Let's call this J of x, just for a new name, and then let's go. You want to get nuts? Let's get nuts. Let's put that as 1/4 in parentheses squared. Oh, okay. Well, first of all, 0, 0 for x gives me 0 for y. That's no change. What do you think the next coordinate I would plug in is? What do you think would be smart? 1? No. What would be smart? 4. What's 4 times a fourth? 1, 2, 3. 1. What's 1 squared? Whoa. That point went way out here. All right. And then negative 4, same thing. 3/4. And then that becomes negative 1, but squared. So what would you describe happened here? Well, here's the weird thing. And then the next one I would have plugged in is 16, which is off this. So, actually, I would have plugged in 8. My bad, dogs. 8 times 4 is 2. 2 squared is 4. So I'm way off. 8 comma 4 would have been a point, right? Right. No one's answering anything. So I should have done that. All right, so then I should have graphed this again. All right. Okay, but what's actually happening here? Okay, when that number's on the inside, we shift the perspective to the y-axis. And this is just a rule. I don't know why, because you could argue that this is stretched horizontally, so what's happening vertically? It's being shrunk, so it's one or the other. But when the number's on the inside, we put it in terms of the horizontal or the y-axis. So this is what's being done? Is it stretched or shrunk? What happened? Stretched. So that's what's weird about y-axis dilations. You're going to have to do a little inversion on this. It's kind of like a, what's the word I'm looking for? Sorry. Inverse. It's an inverse relationship. So you feel free to write down what you want. I'm going to add a couple more. This is awfully wordy. I don't know whose this is. If it looks like Mrs. Gray's writing, I believe. All right, but that A on the outside, that is a vertical stretch or shrink. If A is bigger than 1, great, it's stretch. A is smaller or in between 0 and 1, then it's a shrink. You feel free to write what you want. Probably won't give you the time to write all these sentences. If I were going to write this, I'd really shorthand it. I'm just kind of lazy that way. Plus K on the outside, that's up or down. If K is positive up, K is negative down. Opposite relationship for right left. If it was X minus 3, that is 3 rights. If it was X plus 2, that's 2 to the left. Those are opposite, like as far as signs are concerned. Okay, so that's kind of denoted in the writing. Here's the kicker. This is the one you really want to write down. This is a mind. Okay, and I've always had a problem with this until I kind of just graphed that one and then it made sense to me. But I don't know why it is. Outside the function, that's vertical. Inside, we compare that to the horizontal. I don't know why that's a case. It's just something that mathematicians decided. And because of what we just saw, if it's f of b times x on the inside, then the dilation factor is an inverse relationship. It's 1 over b. So let me go back up to here. Here's what I mean about this. This, therefore, is considered to be stretched horizontally by a factor of not 1/4, 4. That's the inverse relationship. Whereas here, yes, this is stretched vertically by a factor of 2. This is 1-to-1. This is not inverted, that relationship. I don't know why. That's just the perspective of what mathematicians want to see. Okay? And I just want to share that with you. All right, so then I'll leave this up here in a minute, and then we're actually missing our reflections. Oh, it does say it in here though. They're just kind of sneaky about it. They put the reflection in here. They say if A is less than 0, then that's reflected over the x-axis. So I guess it is in there. So I won't have to rewrite that. I guess I didn't see that in 4th hour. Ah! Okay, I hate when that happens. Okay, oh, it's going to do it again because this is stupid technology. So if A is negative, that's not a dilation thing, that's a reflection thing. And then if B is negative, that's a reflection actually over the y-axis. And I can, in the last hour, I showed that with our graphing calculator. All right. So I will tell you right now, the hardest thing right here is D. And if you like what I did in that last parabola, it should make sense. All right. But do get those perspectives as you're writing down. I'm just filling in time here. Number out in front, that's vertical stretch or shrink. Number on the inside of a function, that's horizontal stretch or shrink. That's what mathematicians want us to do. Even though you could kind of compare the two. If I stretch vertically, then horizontally, you're compressing, you're pulling towards. If I compress vertically, then you're stretching horizontally. You know, it's actually true. Okay, everyone all right? Oh, a lot of information here, a lot of lengthy notes here. Hopefully in honors you guys can handle it and we can take care of it. Hey, you guys do it yourself. I should have said this. Move on to that. Stop the writing. I think the key's online if you need to fill in any parts. If you want every single sentence, every single word, then you can look at it later. I'm going to go ahead and hit pause. Unfortunately, on the video that you're watching, you will not see me pause. I'm pausing the screen in presentation mode. You guys go ahead and label these. This was interesting. And then try to do it in pencil. And then if you get them wrong, like make a correction like you correct your homework. I'm going to be real lazy on it. Fine, I'll put that whole word. By the way, the words here. Transformation is every change you can make for a graph. It's a general term. Translation is right, left, up, down. Dilation is stretch or shrink. And then reflection is reflection. Tell me which axis, if there is one. For dilation, you have to tell me vertical or horizontal, stretch or shrink. It's got to be one of those two. Okay, quite well. You guys can talk if you like within your groups. The third one is the big one. Oh, I should use this one as. Yes.
I can do this sometimes. I do. I figured it out. I figured out last time.
Let's just analyze this. Hmm. All right. I was just actually thinking off to the side here. Okay, here we go. Ready? Everyone all done? Got all your answers? Be amazed if you get the third one correct. Here we go. This is where the fourth hour ran into troubles. Let's go one at a time. So let's show them this first. Okay, sorry for the dead time on the video. Just fast forward. Okay, so that should be easy. I hope we got that. But remember, it's got to be vertical, stretch. You got to tell me vertical and stretch by a factor of 2, so it's pulled away from the x-axis. Good to go? Straightforward. Next one may be a little tricky. You got to pull out that negative, my silly little friends, and then make that x minus 4 on the inside. So actually, it's 4 right. There is no dilation. And this is technically a y-axis reflection because that negative is on the inside of the function. Although for a cubic, if I do a y-axis reflection, it's the same as doing an x-axis reflection. So there's an argument there. But stay true to negatives on the inside are y-axis reflections. Okay, so it's got to be named as a y-axis reflection. Then here we go. Then the last one. Did you get that right? First of all, 3 right, not 3 left. And then 2 up. Not 6 right or left either. So you must factor out that negative 2 on the inside to properly see the right-left shift. So it's actually 2 right because that becomes minus 3. Then it's the dilation thing. I have a 2 on the inside, so that's a horizontal shrink. It's an inverse relationship by a factor of a half. And then it's a y-axis reflection. And actually, I'm going to prove all this on this one. Okay, so where does one of my points, like where does 0, 0 go? Well, 0, 0 is now going to be at 3, comma 2. You're going to see that's where the starting point is. And then it goes in the opposite direction. So let's go ahead and open up that calculator. And I think I already have that stuff on there. A couple things. Let's go to y equals real quick. And then let's delete that. I was just doing a thing about analyzing how 2 to the x, 2 times x instead of x on the inside changes things. Let's first do our thing here. Let's look at the new one, which was negative 2x. It was plus 6. And then on the outside of that was, I already forgot. What was it? Plus 2? 2 up? So plus 2. And then it's so fancy in this calculator, it shows the different colors. There you go. So 0, 0 ended up at 3, comma 2. Just got to stop there. And then notice it's going in the other direction. There's the y-axis reflection. So it got flipped over. But I don't really see the horizontal shrink. It's kind of hard to see that with that. I do see the other stuff. So here's what I did last hour. This is why we had this. I just analyzed only the 2x thing. So square root of just 2x and saw these changes. Then I'll show you why this is considered a y-axis or a horizontal shrink. What ends up happening is 1, comma 1 turns into half, comma 1. So it got pulled towards the y-axis. So it does look like it's kind of stretched this way, but it's really the x-axis values get pulled this way towards the y-axis. So that's why it's considered a horizontal shrink. Shrink is towards. All right. So that's I think pretty powerful there. Seeing that in action there. Got that covered. Whoops. And now I got that silly little screen there. All right. Moving along. Now what do we got? Okay. I just verbalized these. I feel like we got enough. All right. Logarithms and e's. We are going to do this. This is another great about dilation we can write. But verbalize this. This negative's in front of the e, so it's a vertical flip over the x-axis. A vertical shrink by a half. Understand that's inside, so this is 2 rights. And then this is for actually up, because there's no negative on there. Right? We will graph e's later. We will graph logs. Logs are brand new to you, though. You've never done, you don't even know what E is anyway, I don't think. E is a nice little number for growth and decay situations. I don't care if you know what a log is, and that's just the base. That negative just to flip over the x-axis. 5 halves is bigger than 1, so it's a vertical stretch. And then it's 2 left. One thing I will write on this one, though, this dilation is a horizontal. Which one is it? Stretch or shrink? It's a stretch. And then what's the factor by? By what? 3, not 1/3. It's an inverse relationship. And I just showed you that twice. I showed you on a parabola with that 1/4 on the inside, and then I showed you with that square root with a 2 on the inside, how that actually happens. Okay, now give this a try. And then here's the kicker. What does this point become? Now, one thing you should write on this is it's really a PEMDAS thing. Or I'm going to add one more thing that is crucial. Kind of in a PEMDAS thing, parentheses can kind of get mixed up in that. But really what you should make sure you do first is reflections before translations. That's really the big thing. Reflections before translations. Translations, in a way, even though they could be in parentheses, I think that's the AS of PEMDAS. You add and subtract at the end is really what's happening there. So then dilations is a multiplier. So MD, you do those next, and then you do translations. This is really the order of things. And I kind of messed that up last hour because I did parentheses, and I think I have to make a correction with them tomorrow because these are kind of tougher questions. What does this really mean? This is just some function I don't know. I don't know what it is. I don't know if it's an x squared, a absolute value, a square root. Any function gets affected the same way. All right, let's see if you can get those coordinates following those rules. I'll pause again. Feel free to talk within your groups or whatever. Okay, make a list of the transformations again. Okay, we're going to do that again. So I'm going to go ahead and write that. List them up. I'm going to really shorthand it. You go ahead with your group. This group's talking, some are not. Okay, so on some mystery graph, -5, 8 is a point on that graph. After these transformations happen, what happens to -5, 8? What does that new coordinate become? That's what you're trying to do. So I will say PEMDAS works as far as the order of how you do things, but really this is the key here. All right, inflections first, then dilations, then translations. I think we're putting translations in the add subtract category of PEMDAS. If we hold true with that rule, then I think we're going to be okay. I want to do a little more thought on it before I go back and make sure we're doing this the right way. Sometimes it gets a little crazy. Okay, does anyone have coordinates? First one should be okay. The problem with the first one is I have an x-axis reflection, right? Who does the x-axis reflection affect, x or y? Which coordinate gets affected when I reflect over the x-axis? That's the y coordinate. So you got to be careful. Like who's happening to what? Then a vertical stretch by 4. Who is that? When you stretch by 4, what's affected, the x or the y coordinate? So when I take the graph and I stretch it this way, who's changing? The y's. You're getting pulled away from the x-axis, so that's 2 y's. What's 7 left? Who does that affect? Who does 7 left affect? The x's. But then who does 3 down affect? The y's. And then that's the biggest problem. If I do 3 down and then flip, or if I flip and then do 3 down, those are 2 different answers. That's why order is important. And that's why we got to make sure we really keep true to this order here, which is kind of along the lines of PEMDAS a little bit. All right, so I'll go ahead and get this back, if I get this back. All right. So I got an x-axis reflection and a stretch by 4. That could be done at the same time. I'm basically taking the y's and multiplying them by -4, right? All right, and then what do I do first? Do I go 3 down and then multiply by -4, or -4 then 3 down? And we do the translations last. That's the biggest thing, and that actually is a PEMDAS thing. So I'm going to take the y's and multiply them by -4, and then the x's, I'm just going 7 left, which I'm going to subtract 7 from that. So right now I got -12, -32. Now I can go 3 down. So the ultimate answer is -12, -35. Anyone get that for the new coordinate? The problem is if you go 3 down first, that becomes 5. Then multiply that by -4, you get -20 as a final answer. That's why order, when 2 things are happening, are very important on that. All right, following those rules. I just went 7 left. Yeah. Okay, next. This one, okay, this is what I did last hour. I did a PEMDAS thing and I did parentheses first, which is I think, wrong, and I'm gonna double check that. So really in the PEMDAS thing, reflections and dilations represent multiply in a way for PEMDAS, then translations are add or subtract. So really what we should do is the dilation first. So who gets affected on a y-axis reflection? When I'm over here and I go over here, which one, X or Y? X or Y gets affected? That's X. So 5 will become positive, right? And I did that different in the other hour. Then 3 right, who is that affecting, the X or the Y? The X. So that's 8 comma 8 ultimately. So I did my reflection first, my y-axis reflection, and then I did my 3 right by adding 3 and understanding that it affects the X coordinate. Okay, but I'm going to kind of dive into that again. I'm going to do a whole bunch of y-axis reflection and then right-left shifts and make sure that this is the order. And I think it is. Okay, so now here we go. Oh, I love these questions. This is just some random picture that doesn't have x squared, absolute value, square root. It's just a random picture. So here's what you need to do on this if we're going to make changes on this. And then I actually added some more points. 1, 2, 3, comma 2, that's negative. It's the smartest way to do these. 1, comma 1, 2, 3, 4. It looks like 5. 1, comma 5. And then this is 6, comma 1. But you know what? And actually, I don't want that there, because I'm gonna do my changes over here. I'm gonna add a couple more, because sometimes I have a problem with where is the shape at? Like, how do I get that shape to work out correctly? So I got a little inversion there, a little curve. So I do want this to be 0, 2. So when I change that point, then I'll get that shape. And then one more probably. This is nice. This is 2, 2. Then I can get that little curvature in there. Okay, so what's happening to these coordinates then? What does minus 2 do? What does that move? Which way does that move? Yeah, what's minus 2? Which way does that move? Right. Who does that affect, the x's or the y's? The x's. And then what's the 1/2 out in the front do? That's a vertical or horizontal? Vertical or horizontal? Vertical, stretch or shrink? Who does that affect? The y's. We're good to go. This is all I have to do. And I'm going to write this like this time. So I'm going to write all the x's, -3, 0, 1. This is for no purposes. If you can handle some math in your head, then go ahead and do it. And all of these, I'm going to move right to. So there's the right to, and then I'll graph them. Luckily, there's only one thing being done to the x and one thing being done to the y. So I don't have multiple things I have to worry about order. All right, and that's good. Half the y's. So -2, 2, 5, a fraction, 2, and then 1. Be careful that you're in order. Half all of those. That's how you get a vertical shrink. You take the y's and multiply them by half. I have a couple fractions there. So this becomes -1, comma, -1. So -3 plus 2 is -1. Half of -2 is -1. Got to be careful in doing this way, but I'm just trying to be like a note person. 0 plus 2 is 2. Half of 2 is 1. 1 plus 2 is 3. 1, 2, 3. Half of 5 is 2.5. You know what? I got that shape. I got that little inversion there, and then I got that little tip. So it's this part that got shrunk and then shifted. Okay, so it got shrunk vertically. It's not as high as it used to be. All right, definitely. So I see it. 2 plus 2 is 4. 1, 2, 3, 4. And then comma half of 2 is 1. There we go. We get that other little inverted point there. Then half of 1. 6 plus 2 is 8. And then half of 1 is a half. All right, I got the general shape. So that looks kind of like the old picture, but it's smushed and moved. All right, so that's how you take care of this. You take those coordinates and do that. All right, now we got a bit of a problem. What does half of x on the inside do? Is that a horizontal or vertical? Horizontal, and then stretch or shrink. So horizontal stretch, who does that affect? The x's or the y's? When we move this way, when we stretch this way, who gets affected? X's. What am I going to do to those x's if I'm like it's 1/2 there? I'm doing what to them actually? So it's actually a horizontal stretch by 2. Fumble. Horizontal stretch by 2. That means I'm multiplying the x's by 2. And then what does the +1 do? Moves up 1, right? Isn't that up 1? So that's the y's. So here we go again. We got -3, 0, 1, 2, 6. And I'm going to multiply them all by 2. That is the horizontal stretch factor. And then I'm going to take all the y's and add 1. 1. Actually, I could just do it that way. So it's -2, 2, 5, 2, and 1. And I'm going to add 1 to all of them instead of having to write that all the way, all the time there. So I'm -6, 1, 2, 3, 4, 5, 6, comma -1. I am 2 times 0, which is 0, 0, comma 3, 0, comma 1, 2, 3. I am 2 times 1, 2, comma 6, 1, 2, comma 1, 2, 3, 4, 5, 6. Okay, I see that little inverted point, and then I see that tip to the top. All right, so it's stretched by a factor of 2 horizontally, which means it's pushed away from the y-axis. And then it is moved up 1. I want to make sure I didn't miss anything there. Okay, and then 2 times 2 is 4, comma 3, 1, 2, 3, 4, comma 1, 2, 3. And then 2 times 6 is 12 off the screen, comma 2. 12, comma 2 is somewhere like right around here. Okay, because this is 8, so it is a little bit off. All right, so get key graph points and then go from there. All right, and then you guys can go ahead and do this. Try to get those answers real fast. I'll pause and then see if you can read those directions and get those equations. Let's go. Try to make your own notes. I'll walk around real quick too, and then I'll answer them real fast. So basically, what the directions say is the parent function's in the middle. That's red. You don't see red on your paper though. The parent function's in the middle, and then what is the new function's equation? Oh, what do we got? 55? Sorry for this, but this is honors. This happens a lot. A lot of information. I think we're all good on the AP classroom and the resilience sheets. I think we are. I think it's only 7th hour. I got 1 problem left. Is it perfect? Is that kid not here? I don't know if he was here today. You got 1 kid, my 4th hour, still not doing things. Okay, I'm gonna hit unpause and then go ahead and get my own answers here. First thing is parent of functions. So you gotta know that first one's a cubic. So this is y equals x cubed for sure in red. All right, if you don't know the parents, you can't get the child. All right, 1 cubed is 1, 2 cubed is 8, fumble. All right. But here's what we got. It's just y equals, I get moved, I believe it's left 4, so that's +4 cubed, and then down 5, which is -5. And then let me just make sure there's not a multiplier here. Look up here, rise 1, run 1. The first order difference, or 1 cubed is 1, so that's good. Here's the point of inflection, and then 1, 1. So it is, this 1 cubed is only 1 higher than that, so that means that is the number in front. It's not stretched or shrunk. That's kind of how you can see stretching or shrinking or input. Say it's, you can throw in a point after and double check. This one is pretty easy because a V is actually two lines actually connected with a negative slope and a positive. So those are sloped there, which does tell me my multiplier. So I do have a multiplier of 4, and then this is just moved 2 to the right, which is a -2. You guys get that right? Piece of cake, right? And then this next one, they just said, go ahead and graph these. I don't know. I just do input, output. I mean, what would I plug in for x after 0? I think we had this on a previous one. What would be the next value I plug in? 3. I plug in 3 and -3, and then 9 and -9, and I would see this graph wider. So therefore, it's horizontally stretched by a factor of 3, and then up 2. This one I would plug in -3, and I would get -2. That proves that it goes 3 left and 2 down, and then plug in a couple points around that. Right? So I'm not really going to do that. You know how to graph. I think that's not what we really need to be doing. It's this one. And then again, it's with that 2 on the inside. Why don't you take a gander at this one? I would grab some coordinates. That's what I'm going to do right now off of the screen. So you guys go ahead and try, get a bunch of coordinates and try to change those coordinates and then see what you get. So again, you make your own notes sometimes. And then if you do it in pencil, if it's wrong, then you make a change. Make that change, gonna lift yourself. You know it. Get key points that give me shape. Give you shape, not me, like you're giving me something. Just the key points that establish enough. Oh, and then I think like, that's good. Okay, so in order, I'm going to do this again. 6, 2. Luckily, we have another easy set of separate translations. Oop, I wanted to move that there. Okay. And then, oh, okay, I do want to do that. I guess I'll put the changes here. Okay, I kind of got it set up. I labeled my coordinates. They don't have to be exactly the same. I just wanted something along this part. Definitely wanted that one. Definitely wanted that high point. Definitely wanted that corner. And then any point along this line, just to get that horizontal taken care of. What does the negative on the outside do? Who does that affect, the x or the y coordinates? Which one does that affect, the x's or the y's? So what is that negative? It's a vertical or a horizontal stretch, or sorry, reflection. Which one is it? Vertical. Who does that affect? No. When I'm up here and I go down here, that means the y's are negated. And then what does the 2 do? Is that a horizontal or vertical? Which one is it? Horizontal, stretch or shrink? Shrink or compression. So who does that affect? The x's or the y's? This is the x's. So all of the y's get negated. There's the flip. And then what happens to all the x's if this is shrunk by a half? What am I supposed to do to all the x's? What am I supposed to do? Nobody's going to say? Multiply by a half. It's an inverted relationship. So luckily, I don't have to worry about order of operations because one thing is done to the x, one thing is done to the y. They're not, I don't have to worry about the order of things happening there. So this is -3, comma, -6, 2, 3, 4, 5, 6. This is half of -2, which is -1, comma, 2, negative, negative. Be careful on that. Half of 0, 0, -2, 0, -2. Right, half of 1, oh no, is 0.5, comma, -1. And then Half of 8 is 4 comma negative 1. 1, 2, 3, 4, negative 1. Then when I look at the global thing, okay, so that becomes this. So this is the line that goes through. Oh, and then this is the start of the arc thing. So this is a compressed a little bit arc, like a parabola. And then it goes forever through that point. So I still have the general shape there, and I do have that little parabolic little part that we had in the middle, just flipped and then condensed a little bit. Okay, 1, 2, 3, 4. 1, 3, 4. Yeah. So this is still 4. So I think this coordinate plane is a little bit bigger too, so a little bit bigger, but it's not. Okay. All right. So order of operations very key in those transformations.